Guys, thank you for the organizers of BarcelonaJS. I'm here to talk about React Native and a lot of C++ and Rust and other funny things. But I'll try to keep it for JavaScript since you all came here for that. My name is Oscar Franco. I'm from Bolivia. I lived in Germany for many years. Now I just moved to Barcelona. I've done a lot of things, team lead, CTO. Now I'm freelancer. I've done a lot of open source, and lately I've been doing a lot of C++, Rust, Kotlin, Swift, blah, blah, JavaScript. I try to make everything work with JavaScript. So today I'm going to talk mostly about React Native, which, if you don't know, is a framework from Facebook that runs JavaScript on mobile devices. More than mobile devices, now there's support for web, for macOS, for Windows, for visionOS, tvOS, yada, yada, yada. At the end of the day, React Native is mostly an orchestration layer, in fancy words. It's just an implementation that allows you to display native views based on JavaScript. Now, I really liked Luis' talk because he touched on a lot of points that a lot of the frameworks face at some point, whether it is Story, whether it is Electron. And basically that is that JavaScript is not a native language. So at some point you need communication with an actual native language that has access to all the system APIs. And a lot of these frameworks, the first solution is always fall back to some sort of HTTP server, JSON communication, message passing, right? So React Native started the same way. You have your JavaScript that runs on some JavaScript engine, and then you need to communicate with a native layer somehow, right? And the first approach was JSON. That is very easy to implement, but at some point it doesn't scale, right? Because if you drive all your UI, all your animations, all the state logic, at some point it gets tangled up. So what I wanted to show you guys today is the new architecture of React Native. I'm not going to go too deep into the C++ code, but the most interesting part is that all of these frameworks are now maturing because they have reached a bottleneck, and people are starting to push more and more for more performant applications. And the way that React Native has solved this is by using C++ and what's called JSI Bindings. JSI Bindings are basically a C++ interface on top of your JavaScript engine that allow JavaScript to call with very little overhead to the native functions, right? And this has kind of exploded the performance and kind of allowed for a lot of innovation when it comes to libraries and the runtime itself. So this is very, let's say, deep code into what would be writing a C++ function that you expose to JavaScript, right? You can see that you have std string, for example, and then you kind of have to start playing around with the JavaScript side of things. Since JavaScript is dynamic, you have to kind of do runtime checks on things, right? You need to check, is this a string? Okay, then I cast it as a string. Is the next argument there? If it's not there, it's a variadic function, like all JavaScript functions. So you have to do all of this kind of magic. But then at the end of the day, the important part is that you have casted all your parameters, and you can just call a C++ function. Do all your computation in C++, and then just return the result to JavaScript. This function doesn't return anything. This is just a void function. But then at the end of the day, that translates to, let's say, very idiomatic JavaScript code. People might not know that they're actually calling C++ from your code. There are more powerful abstractions. One of the abstractions is called a host object, which basically allows you to inherit from a C++ class, the C++ class, and it allows you to kind of expose a C++ object directly into the JavaScript interface, right? You just return it, it keeps the state, it has all the pointers, it's memory managed by C++, and on your JavaScript code, it just looks like a JavaScript object. It kind of follows the prototype chain. It does everything it does for you. But the interesting part about having this C++ instance is that you can handle it like any other C++ instance, right? You will pass it to a variable. If you drop that variable on JavaScript, then it will be garbage collected at some point, right? So you kind of get the dynamics of JavaScript while still using C++. And you can expose methods, you can expose pointers. You might not be able to interact with every single C++ field that you have in there because not all of them are compatible with the JSI. But there's nothing stopping you to kind of create an API on top of whatever you have in there. So this is a very powerful abstraction. Basically allows you to expose all the native world into JavaScript. Now, I told you I've done a lot of open source in the last few years. One of my biggest libraries is called OP SQL Light, which basically was a rewrite of the SQL libraries that were available for JavaScript on the old JSON bridge. It was migrated to the new architecture. There were a lot of iterations, and then there's also now a lot of people doing their own SQL libraries. You can see Quick SQL Lite was the first iteration. There was a previous version, which I'm not even showing here because it was based on the old JSON bridge. And that's, at this point, it doesn't even run, right? When you have a sufficient large amount of data, the JSON bridge collapses, right? Your application freezes, you don't have enough memory, yada, yada. So it's not even worth showing it here. And this is a query, for example, that selects 300,000 rows from a SQLite database. Just selects it, just return it to the JavaScript side of things. So you can see things have started to go down, and there's even more room to play. At some point, you don't return full objects. You just return the data, and that's useful for, let's say, ORMs, because ORMs already know the shape of your data. They try to minimize the overhead that happens in the SQL layer itself. Right? So you can just return the data without the labels, and so on and so forth. Now, I can tell you a little bit of which companies are using this library. For example, Coinbase has started using it because they need to keep track of a lot of data, and SQLite is very well suited for them. Expensify was using the old version, now they have migrated. PowerSync, which is a synchronization engine for the SQLite layer. Turso, which I don't know if you guys know libsql, which is an open fork of SQLite. Now it's compatible with the latest version of the library. And Mendix, which is a low-code platform that also kind of provides a low-code mobile application development on top of React Native. This list could go on and on, doesn't really matter. What other libraries are there nowadays? You have MMKV, which is a memory mapped key value storage. This is by far the fastest for small amounts of data, right? This is not SQLite, this is just a very simple key value storage. You have now FastIO, for example, which allow you to do C++ WebSockets. This also increases the performance for very large payloads. You have Reanimated, which does off-thread animations on the C++ layer, exposing them to JavaScript. You have, for example, Quick Crypto, which is a port of the Node crypto module. And this was very, very useful for, let's say, crypto companies, wallets, signing, this kind of stuff. This is very heavy crypto operations. So C++ kind of gives us an advantage there. So you'd say, this is amazing. How can I do this? How can I achieve this? It's fairly easy. Your SDK needs to compile to iOS and Android. It doesn't matter what you're using. You can use Go, you can use C, C++, Rust, doesn't matter. If it compiles and it has a C API, then we can write an API on top of it, right? And that's kind of the beauty of it. Nowadays, at least from my experience, I'm seeing a lot more companies that are starting to write their SDKs, let's say in Rust, for very performance critical operations. And Rust allows you to expose a C API. On top of that, you can build a world, right? And if you combine this Rust core, which is memory safe, very fast, and you can create applications on top of it on JavaScript, it gets even better. What I was talking about. I can tell you one use case. This is a company I work. I'm guessing you all know Prisma. I think it's very well known in the community. Now they are moving to TypeScript. for different reasons. But they actually had a Rust core, and they came up to me wondering, they saw OP SQL Light, and they were like, okay, we want to do the same for Prisma. Maybe we want to use your library. I was like, guys, you don't need my library. My library is already an abstraction on top of SQL Light. Building on top of that is only going to make it slower. If you already have a Rust core, you don't need anything else, right? So I helped them port Prisma for React Native. Prisma is kind of a funny company, but it worked. At the end of the day, there's a version out there that is working for React Native. It runs the native code on iOS and Android. And on top of that, it's just their ORM, which is written on TypeScript, that kind of calls the internal functions of the Rust core. There are even more things to come. This is a project that I'm still kind of in the research phase, which is AWS LCRS. AWS LC is the crypto library of AWS. The guys from AWS, being so huge, they have very strict requirements for their machines, for their deployment servers. But what's very interesting about this library is that's FIPS certified. Probably nobody knows about this. We don't care usually too much. FIPS certification is a certification from the US government that goes line by line, certifies that they're secure. And this is for very, very critical applications. Your company and your app will probably not be able to get this, and you probably don't want to do this, but it does give you kind of a seal of guarantee that it's secure, right? If you're writing certain types of applications for certain things, this is very useful to you. And the idea, again, from everything that I have shown you before is once you get it to compile, once you have an API on top of it, you can make it available to JavaScript developers like us who don't want to learn Rust, don't want to learn C++, and you can just use it. Now, what are the disadvantages? This is not easy, right? You have to understand C++, you have to understand a lot of the internal mechanics of what is a JavaScript engine, right? Like how memory works, how the garbage collector works. That takes just a lot of effort. So there's not a lot of expertise going around how to migrate a lot of these packages. And that causes when a lot of the community packages that work just fine, when they try to do the jump, now that everything is moving towards this direction, it's just slow, it's just painful. So not everything will be available. Documentation is also not great because Facebook does Facebook things, right? Facebook scale, or they have all the expertise. So there's a lot of tweeting going around. There's a lot of Discords. There's a lot of Slack channels. You just have to ask people to move things along. Now, we are a JavaScript community, so we're going to hate on Flutter a little bit. Why not use Flutter? Well, because not even Google uses Flutter, right? It's there, they maintain it. You hear horror stories every once in a while. It works, it works. It's more than fine, but who uses Dart? Who knows Dart? I don't think a lot of us know too much Dart. We are BarcelonaJS, so just kind of go React Native. And the last point I wanted to show you, and this is very relevant for all the JavaScript developers out there, this is an initiative from the React Native team at Meta. At some point, Meta created their own JavaScript engine that runs on React Native, just because they needed some extra juice when you start your JavaScript app within React Native. And Meta and being so huge and having so much money, they can do the really fun stuff. And one of the fun stuff they realize is that you can make the type system of TypeScript and float type more tight, and they call this sound typing. And once you have sound typing, you can actually compile JavaScript, or let's say TypeScript code, down to assembly, down to C code. And then, once you have assembly code, you don't need any type of bridges. And this is what I really liked about Luis' presentation, because it kind of showed you, okay, me as just an application developer, I have to come up with workarounds. I have to start an HTTP server. I either look into ICPC communication. It just gets messy at some point. The beauty of it is, if you can compile it down to assembly, you can just call all of these APIs, right? Maybe not on all of the environments, but it unlocks a huge potential. And then, again, it's a 20x performance gain because you're no longer running interpreted code. This JavaScript, this TypeScript code that gets compiled to assembly is as fast as C. So you can imagine you just write your application in TypeScript, and then at some point you realize there's a halt path, or there's an algorithm that JavaScript is just too slow to interpret. You can just compile it down to assembly code, and it will just run as fast as any other C code. I think this will be amazing. At some point, all the browsers will realize, okay, we just need to swap the JavaScript implementation. So you might see this on Node or Bun or Chrome. It will take time, of course. There's a lot of things that would break, I think, but it could be great as an optional, right? If you can deploy your server application, which is written on Node, and then you realize, okay, I'm just going to compile these 2 or 3 modules down to assembly code, and then I have all the benefits in the world. I still get my JavaScript server for the usual, maybe not so fast, important stuff, but all the hot critical paths can be immediately faster. Okay, good. I think that's, I mean, I can talk for this about hours, but that's all I wanted to show you for kind of the JavaScript side of things. Do you have any questions?
Does the new architecture require Hermes, or is it?
No, Hermes is a project that's coming up in the coming months, years, let's say. Hermes, the normal version, it already runs. It's just one more JavaScript engine.
How is what you were talking about JS, basically interfacing with the JS engine to convert all these objects from JS to C functions and vice versa? Is that something that has to be implemented for each engine? Like, do it once
no.
Android and once for iOS?
You mean this one, right? No, the JSI is, let's say, a definition that the guys at Meta came up with that allow you to interact with JS Core, with JavaScript Core, which is the Apple engine in Safari, or with Hermes. So it won't run on V8, but in theory, if somebody is willing, they can port kind of the same headers and implement the functionality, and you should be able to do more or less the same things. The thing is, V8 already has this. This is the Node API, and it also depends on the internals a little bit of how memory is managed, how the runtime works, how do you schedule callbacks. V8 is kind of a different beast, right? It's, let's say, more complex in certain areas. But in theory, it is engine independent. You can start.
What about WebAssembly?
There have been attempts to get WebAssembly to run on React Native. The problem is a little bit not only it requires that the engine is built to support it somehow, right? And it doesn't really work. That being said, today I saw a tweet of somebody that recompiles WebAssembly bytecode back to C code and then to native code. So things are getting kind of crazy, right? Like people are now starting to discover, okay, once we compile it, it will run. So it's kind of following the rabbit. Okay, how far can we take this? Exactly. Unfortunately, raw WebAssembly doesn't work right now on React Native. But this is more of a question like, is it really worth it for Meta? Do they want to run WebAssembly? No, not really. So if somebody's crazy enough, I'm pretty sure they can get it to work. The first part?
About C++, I don't want to learn it. Can I still go with this path, or is it better to make it?
I would suggest that you go with Swift or Kotlin. C++ gets very, very complicated very, very fast, right? Because you have to manage memory yourself. And if you don't know what you're doing, it's very easy to go on the wrong path. I have learned doing this library for the last 2 or 3 years, and I keep learning just by mistake, right? It's like somebody reports a bug, and I trace it down, and it's like, oh, okay, I wasn't supposed to do that, right? So yeah, there's a lot of complexity there.
This example of components of class function, when we call them, don't attach the strings. Do we like need to copy them to the memory of the class still, or do we have like a way to know magically pass the?
No. Yeah. I didn't want to show too much of this because then I get into JavaScript internals and how a JavaScript engine works. I will give you a very my short comprehension of the thing. JavaScript actually is a virtual machine. Nobody calls it this, right? This is what you would think about Java, but it is at the end of the day because it has its own stack, it has its own heap, it has its own kind of internal state, right? So when you do, let's say, as string as UTF-8, you assign it to the C++ variable, and then let's say you start a thread, and then you just kind of move the memory to that thread, your JavaScript machine will still be running on that original thread, on the main thread, right? So garbage collection might run, so that string might be deallocated. Your function might return, so that will get deallocated, right? So there's a lot of these little things that you need to start thinking about. Okay, my JavaScript is actually kind of its own thing, separated from my C++ code. It runs on top of C++, but I cannot mess with it. I cannot mess with the memory of it. So yeah, a lot of things you just have to copy around to make sure that they don't get deallocated. No, because like I said, it has its own stack, it has its own heap, so at some point you don't know what it's doing, right? Like it's doing JavaScript things. And if you try to just invoke from your C++ code and say, set this variable to something, it might be in a completely different frame, right? So you will just overwrite memory and then at some point it just explodes. So there are some ways to share memory, like you have to do funny things, but this is definitely not the recommended way of doing things. Okay, anything else?
Very quick question. In your React Native application, you can combine, I suppose, the old way with the new one, right?
For now, yes. At some point, it will go away. It just takes a lot of effort to keep everything working at the same time. Okay.